Coming to the part 6, which is improving the convolutional neural network's performance. So here we are supposed to write proposal to make changes to improve the CNN's performance. So in part 6, in order to improve the performance of the previous CNN model, we are making the necessary changes, which include increasing the number of layers, decreasing the learning rate, and we are also increasing the number of epochs. So here the CNN model that was trained on the Cipher 10 dataset in the task above achieved an accuracy of only 53.47%, which is quite low. And there are many ways to improve the accuracy of the model. So the first one is CNN model uses only 4 convolutional layers. Here we can increase the number of layers to 6. And we can also use additional filters to learn the features of the images more accurately. Then we can use techniques like learning rate schedule to change the learning rate so that the optimizer can better update the weights of the model, and it can also update the gradients. So after doing this, we can increase the number of training epochs for the first task. We were restricted to only 5,000 steps, so we can increase the number of epochs so that the model has more time to learn from the training data. So all these techniques together can significantly improve overall accuracy. And next, coming to the report on the results of the testing the model. So after implementing the above suggesting changes, as as you have just seen, uh, so to improve the CNN model for the Cipher 10, we can see accuracy of 76% for the same data sets, which amounts to a substantial increase of over 20%. So the result of the changes infer that all the suggested changes were critical to increasing the model's performance. As we can see in the below results, here we have taken the 50 epochs. Uh, so in the 50 epochs, we can see the accuracy loss and the sample per second. This is for the, so here I've taken the 5 samples. Like I've pasted the results of 5 epochs out of 50, which are from 46 to 50. And for every epoch, we can see the accuracy and the time limit. Accuracy and the time for the epoch 48 and the epoch 50. So considering all the 50 epochs here, we can see the best accuracy pre-session is 76.47, and within this time limit. So here we can see the neural network architecture in which there are 32 input layers and 10 output layer, and the hidden layers include 32, 64, 64, 128 and 128. So this is it. So the hidden layer, it is in between the input and the output layers, where artificial neurons take in a set of weighted inputs and produce an output through an activation function. And so here in the output layer, the desired predictions are obtained. There is so there is one output layer in a neural network that produces the desired final prediction. So this is about the part 6, and coming to part 7, which is the project report. So here CNNs are widely used for image classification tasks due to their ability to automatically learn relevant features from raw image data. So in this project, we explored the use of convolutional neural networks for the task of classifying images from the Cipher 10 dataset, which consists of 60,000 32 into 32 color images in 10 classes, and with 6,000 images per class. Our goal is to build a CNN classifier using only TensorFlow, which is an open source deep learning framework developed by Google. So the Cypher10 dataset poses several challenges for image classification because of its like small image size, high variability in object appearance, low resolution, which in turn making it a popular benchmark dataset for evaluating the performance of deep learning models. So like overall, we aim to build a robust and accurate classifier which can achieve high accuracy on this challenging dataset. In order to accomplish this, we design and train a CNN architecture consisting of multiple convolutional and pooling layers, which is then followed by fully connected layers with various regularization techniques to prevent overfitting. So we use the TensorFlow framework to implement and train the CNN model, leveraging its high-level APIs and built-in functions for efficient training and evaluation. So the results of our project demonstrate the effectiveness of CNNs for image classification on the Cypher10 dataset and showcase the capabilities of the TensorFlow framework for building and training deep learning models. So here we present a detailed analysis of our model's performance, including F1 score, recall, accuracy, precision, and we then compare it with other state-of-the-art approaches on the Cypher10 benchmark. So from all our findings, it suggests that our CNN model achieves competitive performance on this task, highlighting the potential of deep learning for image classification applications. So we derive the conclusions on what we have done in the project and what we have learned from the results of testing the CNN models in the different parts of the project. So in part 4, which is building, training, and testing CNN on Cypher10 dataset. So there, the CNN architecture consists of multiple convolutional pooling layers, followed by fully connected layers with various regularization techniques in order to prevent the overfitting. So the performance of the CNN model improves with increasing complexity and depth of the network. So the use of augmentation techniques such as rotation, random flipping, and scaling can help improve the model's generalization ability. So the choice of hyperparameters such as learning rate, optimizer, batch size, they all can have a significant impact on the model's performance. So for part 5, which is comparing convolution neural networks performance, so the performance of the CNN models, it varies depending on the dataset which we are using. So the Cypher10 dataset, it is more challenging than the MNIST dataset, which is because of its small image size, high variability, and low resolution um, in the object appearance. So the deeper CNN model achieves better performance on both datasets compared to the shallow model. So the CNN model trained on the Cypher10 dataset, it achieves lower accuracy compared to the model trained on the MNIST dataset. Uh, it is because of the higher complexity and variability of the Cypher10 dataset. And part 6, which is improving the convolutional neural networks performance. So based on my observations while working on the part 5, which is comparing convolutional neural networks performance, uh, we can propose several ways to improve the performance of the CNN model with performance, including increasing the depth of the network, adjusting the learning rate, and adding more regularization techniques such as dropout or batch normalization. Implement the changes we have proposed in our new CNN model and observe a dramatic increase in the overall accuracy of the model on this Cypher10 dataset. So this is the conclusion. So in this project, we have developed and trained convolution neural networks using TensorFlow for image classification tasks on the dataset. Uh, Our main goal was to explore the effectiveness of deep learning models and evaluate their performance on the dataset with varying techniques to build more accurate models. So the results demonstrate that CNNs it can achieve high accuracy levels on image classification tasks, and that the model's performance can be improved by increasing complexity and depth. So here we found that the deeper network with more convolutional and pooling layers and regularization techniques such as dropout and batch normalization, they tend to perform much better. So overall, this project demonstrates the potential of CNNs for image classification tasks and showcases the capabilities of TensorFlow for building and training deep learning models. So future work could involve other aspects like exploring other data sets or incorporating transfer learning techniques to further improve the model's performance. So this is all about the project. Thank you.